Suppose we have many network objects. How can we issue the right number of GET requests to collect them all? Continuing from the last demo, let's re-add our 6 new network objects to the FTD device using the addNetworkObjects.py script. This is nothing new, but we need a handful of objects to understand how HTTP pagination works. Rather than use our traditional getter script, let's explore an enhanced version that supports paging called getNetworkObjectsPages.py. The script is very similar to the first getter, so once again, I'll focus on the differences. Right away, we see a constant named limit. By default, FTD sets this value to 10, which limits the number of objects returned in every HTTP response. In a device with thousands of objects, paging can have a significant performance improvement as the FTD only needs to reply with subsets of the data rather than all of it. I'm reducing the limit down to 3 just to illustrate the point because we have 8 total objects. That means it should take us 3 total GET requests to collect all 8 objects. Let's explore the main function first. It starts out just like all the others by disabling certificate warnings and collecting an authorization token. Next, we define the GET headers, which again are the same as the traditional getter script. After that, things get interesting. I've defined a helper function named FTD_GET_recursive, which takes in a variety of arguments. First, we pass in the resource, which is the network object URL. Then, we pass in our standard GET headers, which shouldn't be surprising. Last, I pass in an item list, which starts off as an empty list. When the function is done executing, the list will be populated with all the network objects. Let's explore how this function works, but I'll warn you, it's a bit different than what you've seen in my courses so far. This function uses recursion, a programming technique that is often used as an alternative to looping mechanisms such as for and while. In order to run multiple times, a recursive function calls itself over and over again, just using different arguments. In order for execution to stop at some point, that is to say, in order to prevent infinite recursion, we must define a base case. The base case is what ultimately unwinds the call stack as it does not recursively call itself, but instead returns a constant value or nothing at all. In our case, if the resource passed in evaluates defaults, we don't need to issue any more GET requests, and we stop the recursive calls. Notice that the resource can be the Boolean value false, the empty string, the empty list, the integer 0, none, or a variety of other values that evaluate to false in Python. If the resource evaluated to true, that means we have some data to work with. First, we need to check to see if a resource is a list instead of a string. FTD uses a list with one element rather than a string when indicating pages, so this code just converts a one-element list into a string. To make the logic easier to follow when we run the script, I include some print statements indicating the resource we are about to query, followed by the current length of the item list. This allows us to watch the list grow with every successive call. We issue the GET request, passing in our specific limit along with our current resource URL and standard headers. If there are any problems with the request, we raise an HTTP error. We convert the response body into JSON, which, if you recall, contains a list of dictionaries under the dictionary key of items. Using the list extend function, we add these items onto the end of our existing item list, which means the item list has grown. In addition to the items key, there is also a paging key. This will contain data about the next page to grab, providing a list of URLs. This becomes the resource for the next function call along with our headers and item list. The process repeats until there are no more pages. Let's check out an example response in our data ref directory named morepages.json. Here, we can see the items key, which is a list of network object dictionaries. At the bottom, we can see the paging key, which contains next and previous links. Scripts can move back and forth through these pages to collect different subsets of information. We know this is the first page because the previous link is the empty list. Let's check out one more file named donepages.json that shows what happens when there are no pages left. In this case, the next link is the empty list, which evaluates to false in our Python script. However, the previous link is populated. Back in our main function, we now have an item list that should contain all the same objects that our traditional getter did, except we introduced HTTP paging to account for huge datasets. This for loop hasn't changed at all from the previous demo. Likewise, we still store our collected network objects in an output file so that our delete script can properly dispose of them. Nothing new there. Let's run the script and observe the output. With all those extra print statements thrown in, it should be relatively easy to understand what is happening. Let's scroll up to see that extra output. At the top, we see 3 separate HTTP requests being sent, each one grabbing up to 3 network objects, which was the limit we set. The recursive function slowly builds the item list, going from 0 to 3, then 3 to 6, then 6 to 8 total items. The base case is reached at the very end, and this stops the recursion. Then, the main function runs its standard for loop and data storing code. As you work with more APIs, you'll want to be familiar with pagination techniques since your API clients will often need to implement some kind of page handling. As an optional homework assignment, see if you can use a while loop technique instead of recursion to solve this problem. You should loop while the next link is populated and build the item list that way.